Hello mathematicians. Today we are going to look at parts of similar triangles. If two triangles are similar, then the following corresponding parts are also proportional to the corresponding sides. First thing we're going to look at is altitudes. Altitudes comes from the top straight down and they make a 90 degree. Straight down make a 90 degree. So wherever you can connect this corner straight down, that's an altitude. So if I take my first altitude, that is BD, that piece compares to the smaller altitude, which is FH. Now come back to this triangle and pick one of the sides. BA. And which side matches that over here? FG. So line them up, altitude, altitude, side, side. The next one is angle bisector. The angle bisector again cuts this angle in half. So here, this line is the angle bisector, so that is QS. What is the bisector over here? UW. Then go ahead and pick a side. Pick another side from this triangle. Let's go QP. And which one is QP proportional to? UT. Those two match. Okay. So make sure you find that angle bisector. That's the one that cuts the angle in half. Compare those and then compare to the two sides that match. The last one to talk about is medians. We talked briefly yesterday that a median cuts this side in half into two equal parts, so it cuts it in half. So the median here is HJ. It cuts that side in half. And what is the median over here that it matches with? LN. Come back to the big triangle, pick a side. Let's go with GH. Which one here matches GH? Okay. So you're going to use this information about altitudes, angle bisectors, and medians in setting up proportions to find missing pieces. So for number 1, I have two medians because it cuts this side in half. So my median here is X. And what is the median on this side? What piece cuts it in half? DF cuts this side in half, so that is 15. Now I need to pick another side over here. It doesn't matter which one, so let's go 16. 16 is side ST. So which one over here matches ST? The first two is DE. And that distance is 20. So we can match up our sides. 16 matches 20. And you can use your similarity statement to do so. How will you solve? Cross multiply. 15 times 16 is 240. Divide by 20. X equals 12. So match up median and median, side with its matching side. For number 2, what is the middle piece that I'm given called this time? If it forms a 90 degrees, this is an altitude. So the first altitude is 10. It connects with a 90. And what is the altitude on this triangle? 8. Come back over here. I need X. That is side HI. So HI must match LK. LK is 14. Go ahead then and solve, cross multiply. 8x equals 140. X equals 17.5. So compare those two altitudes with those sides. The next thing I'd like to talk about is proportional perimeters. If two triangles are similar, then their perimeters are proportional to the corresponding sides. So I can set up a proportion involving perimeter. So triangle DEF is right here. Is similar to GFH. Which triangle can I find the perimeter of? GFH. It wants me to find DEF. So I'm going to put the perimeter first. Do I know the perimeter of DEF? Nope, it's P. We don't know it yet. Do I know the perimeter of this triangle? We can find it. Add all sides together, and that is 8.5. Now, come back to our little triangle. I know 6. And which piece matches up with 6? EF must match FH, that's 4. So the perimeter of the small, perimeter of the big, well, actually this one might be smaller, I guess. Perimeter of the left, perimeter of the right, side of the left, side of the right. Go ahead and cross multiply. 8.5 times 6. Divide by 4. The perimeter of the left triangle, 12.75. So perimeter of the left compared to the perimeter of the right, side of the left compared to side of the right. Nice job. The last thing I want to look at is the triangle angle bisector theorem. Okay. An angle bisector is in a triangle separates the opposite side into two segments that are proportional to the lengths of the other two sides. So here, this bisector creates two equal parts. Well, not necessarily. Here, it could possibly. It creates two equal angles. Now I need to look at the two pieces that it cuts. Okay? AD is one of the sides on the bottom, and DC is the other bottom. Okay? So bottom here, bottom of this triangle. So I have two triangles. And this only works if I have that bisector. So now coming back here, what's another side besides BD, because both triangles have BD? AB. And then the other side of this triangle, BC. So bottom to bottom, side to side. We're going to use that information to find X if we are told KM is an angle bisector. So it cuts the angle in half, which makes us be able to set up a proportion. So bottom is 4.8. And what's the other bottom piece that's created? X. Now go back over here, and what piece will I use here? 12. And what one will that match over here? 18. And how can we solve? 12x equals 18 times 4.8. 86.4. And to solve, divide by 12. X equals 7.2. So set it up with your bisector. The pieces that are down here that are cut by that bisector, 4.8 and x, 12 to 18. If I want to look at this triangle, I can spin it here. Okay. First, my one piece is 27. And what's my other piece, though? Well, they don't tell us. How can I find that piece? The whole thing minus 27 leaves how much left over for this piece? 18. So make sure that we look at this and we say the whole thing's 45, so subtract, so that piece is 18. So 27 is the left, 18 is the right. Go back to the first triangle, the one side, 3x minus 9, and the side over here, x plus 11. When you cross multiply, make sure to distribute. So 18 times 3x, 54x, and 18 times negative 9, negative 162. And then here, make sure we distribute a 27. 27x, and 27 times 11, positive 297. Go ahead and solve. Subtract 27x. That leaves us 27x. And how do I get rid of a minus 162? Plus 162. And that is 459. And how do we solve for x? Divide by 27, x equals 17. So if we have an angle bisector, these two pieces make our first one piece over piece, side over side. Cross multiply and solve. Nice job today, mathematicians.